In this video, we will be going over dead loads. This is part of the structural analysis series. We will be going over two problems. Okay, so for problem 1, it reads, the floor plan shown is subjected to a uniformly distributed load of 40 pounds per square foot over its surface area. Determine the loads acting on all floor beams, girders, and columns. So the first thing we have to take a note of is that the dead loads are distributed in this order. It goes from the slab to the beams to the girders and finally to the columns. The beams in the slab load is already accounted for, which is the 40 pounds per square foot over its surface area. We will start by calculating the dead load for the beams, and then the girders, and then the columns. The beams, there are a total of, these are the beams that I'm circling. There are a total of 10 beams. The girders are these. There are a total of 6 girders. And the columns are these in the corners. There are a total of 9 columns. So we know that it has distributed a load of 40 pounds per square foot over its surface area. We will start off by calculating the load on beam AF, this beam right here. This is beam AF. We will be using this image to show the tributary area for the beams. So to find the tributary area for beam AF, this beam, we have to look at the next beam over, which is this beam right here, and we know that the tributary area will be half. We'll have to split this area in half. So we know that this whole thing is 20 feet, so that means this part is going to be 10 feet. Then we will account for 1 foot of the total beam. So to calculate the load that is distributed over this beam, we will multiply the 40 pounds per square foot times the 10 feet times 1 foot, and this will equal 400 pounds. This 400 pounds per foot load is uniformly distributed over the length of the beam. And what this means is that if we draw the beam AF, and we draw the uniformly distributed 400 pounds, it will look something like this: 400 pounds per foot. And then you can calculate the reactions so the length of AF is 30 feet. You multiply the 400 times 30 and divide it by 2 to get the reactions, and you will get 6,000 pounds. So that is what it means by 400 pounds per foot uniformly distributed over the length of the beam. You will then do this for all of the beams. We will do beam BG next. So now we have beam BG. We will take half from this. This we know is 10 feet. And then we will take half from this, which we know is also gonna be 10 feet. So we have a total of 20 feet here. So we have a total of 20 feet. and we will also do the 1 foot. So then we will calculate the load, which is going to be 40 pounds per square foot times the 20 feet times the 1 foot, and this will give us a total of 800 pounds uniformly distributed over the length of the beam. This will be our answer. We will then do beam CH. This is beam CH. So then we will do the same. We will take half, which we know this is 10 feet. We will take half of this, which this length, as you can see in the picture, we see that this whole length is 30 feet. So half of this will be 15 feet. 15 feet. So then we know that this length will be 25 feet. And then we also do the 1 foot here. Then we will calculate the load, which is again 40 pounds per square foot times 25 feet times 1 foot. And this will give us a total of 1,000 pounds distributed over the length of the beam. You will do this for the remaining beams, and then after all the beams have been calculated, we will move on to the girders. Since we already have the slab, we will move on to the girders. Since we have the slab, calculate the beams, and now we will move on to the girders. We will start off by calculating the load on girder ABC. Put the girder over here. Girder ABC. For calculating the girder, we will use its entire tributary area. So if we have girder ABC, which is this one right here, we will calculate its tributary area. We know that there is a girder FGH, so these two girders will divide the load between themselves. So the tributary area will be half of this, which we know this length to be, since this is 30, it will be 15 feet. And this will be the tributary area. And this length we know it to be 40 feet, 20 plus 20. We get 40 feet. So to calculate the total force on the girder, we will do the 40 pounds per square foot times the 15 feet times the 40 feet, which will give us 2,400 pounds. This is the total force on the girder. ABC. We will then move on to calculate the total force on girder FGH, this one. So girder FGH, we will do the same as we did as the previous one. Girder FGH is this girder right here, and we can see that there is a girder ABC here and a girder KLM here. So we know that they will have to divide the loads between them. So it will take half from here, which we know this length to be 15 feet, and this length will be 20 feet, just half of 40. This length will be 20 feet, so then this length will be 35 feet, and we know this length to be 40 feet. So this will be the tributary area of girder FGH. So we will now calculate the total force on the girder, which will be 40 pounds per square foot times 40 feet times 35 feet. This will give us 56,000 pounds. And this is the total force on girder FGH. The same can be done for girder KLM, girder CDE, girder CDE, girder HIJ, and girder MNO. So after we have calculated all of the girders, we can now move on to the columns. As mentioned before, the columns are column A, column C, column E, column J, column H, F, K, M, and O. We will calculate the total force on each of these columns. We will start with column A. So column A is here. I will draw a circle where each of the columns belongs. And again, we are focusing right now on column A. We will calculate the tributary area for column A. So we see that column A is right here, and the next column over is C. So it will have to take half of this total length for its tributary area. So we can see here, this length is 20 and this length is also 20, so it will take the length of 20 feet. And then we see that it has one column here and one column here, so it will have to divide this length. As you can see, it will be half of 30, which is 15. So this will be 15 feet. So then we will draw, this will be the tributary area for column A. So then we can move on and calculate the total force on the column A. We take the 40 pounds per square foot times the 20 feet times the 15 feet, and this will give 12,000 pounds. And this is the answer for column A. You will move on and do the same for each of the columns. I will go over one of the more complicated columns to calculate, which is column H. It's not necessarily more complicated, it can just be a little bit more difficult to see the tributary area. So this is column H. And we'll draw in the other columns so we can decide the tributary area. There's a column at C, a column at A, a column at E, F, J, K, M, and O. So the tributary area, we will start off by looking at this length here. We know that we have to divide this in half. So we know that this is going to be 20. This length right here is 20 feet. And this length is also 20 feet. So it will take the 20 feet from here. And then we see that the next girder is over here. And we see that the next girder is right here. So we know that this entire length is 60 feet. So half of that will be 30 feet. So we account for that, which means that this length will be 50 feet. And we will do the same for the one above it, above column H. So we know that this length is 30 feet. So then we know that it's 30 feet. So then we know that it will have to take 15 feet from this. And then we have to take account into the one in the bottom of it. So then we know this is 40 feet. So then we know this will have to take the 20 feet. And this, the 20 feet. And this means that this will be 35 feet. So then let me draw a clear picture in the bottom so that we can see the tributary area clearly. The tributary area will be half from this. Again, this is the girder this is the column that we are looking at, column H. And half here. The tributary area will be this shaded region. And again, this was 35 feet and this was 50 feet. So then we will calculate the load, which is We multiply the 40 pounds per square foot, and then we multiply by 35 feet, and then we multiply by 50 feet. We get a total of 70,000 pounds. And this will be the answer for column H. So you would just go ahead and do the remaining columns as mentioned before, the remaining girders and the remaining beams, and that will be the entire problem solved. We will then move on to problem 2. So problem 2 is slightly different because now we have a concrete slab, and we have the areas of the beam, of the steel beams and the steel girders. Problem 2 reads, the floor system of an apartment building shown below, determine the dead load distribution in all beams and girders. So this problem is slightly different because we are not given the distributed load over its surface area as we were in the previous problem. For this problem, we will need to know the unit weight of steel and the unit weight of concrete. The unit weight of steel is equal to 490 pounds per cubic feet, and for the unit weight of concrete is equal to 150 pounds per cubic feet. This can be found in the table which your professor most likely gave you access to. So our first step in this problem is to calculate the load for beam AB. Beam AB is highlighted with the green as shown here. The first step is to find the tributary area for beam AB. So we see that the second beam is right here and beam CD. So we will take half of this length, which is this length, you can see is 10 feet. So that means that this will be 5 feet. And once again, we will do the 1 foot here. And this will be, the shaded part will be the tributary area that we are going to calculate it for. And now, something different from the previous problem, we will have to take into consideration the thickness of the slab of concrete. So right now I'm drawing a cross-sectional view of the slab of concrete. This will be the 4-inch slab of concrete. It can be seen in this image. This length will be the 5 feet, and we will draw in the steel beam, which will be in this corner right here. From this image, we will take that the steel floor beam A is equal to 10 inches squared. So first we will calculate the load for the concrete slab. We will multiply the 150 pounds per cubic foot, which is the unit weight of the concrete, times the thickness of the concrete slab, which we will convert into feet, by divided by 12. Then we will multiply by the 5 feet, and then by the 1 foot. This will give us 250 pounds. We will then calculate the dead load for the steel beam. We will do this by multiplying the 490 pounds per cubic foot times the area, which is 10 cubic inches, and we will convert that into cubic feet by dividing by 144 and then multiplying it by 1 foot. This will give us 34.03 pounds. We will then add these 250 pounds plus the 34.03 pounds, which will give us a total of 284.03 pounds. We can now draw the beam. We can now draw beam AB, and we know that the distributed load will be 284.03 pounds per foot. and the length of this beam is going to be 15 feet. So to calculate the reactions at A and the reactions at B, we will multiply 284.03 times 15 and divide that by 2, and we get a total of 2,130.23 pounds. And this will be the reaction at A as well as the reaction at B. And this will be the final answer for the dead load at beam AB. You will then take the same steps to calculate the dead loads on beam CD and beam EF. And you will also need to calculate the reactions at those beams as we calculated here. I went ahead and calculated the reactions and the dead load for beam CD in this image, and as well as the reaction and the dead load for beam EF in this image. We will need to know the reactions for these because, as mentioned in the previous problem, the dead load goes from the slab to the beams to the girder to the columns, and so we will need the reaction from the beams in order to calculate the reactions for the girder. We will now move on to calculate the reaction for the girder. Girder ACE. And as you can see, the girder ACE and the girder BDF will be the same because if you divide the tributary area, it will be half of this, and the reactions, it will have the same reactions, so it will be the same. So technically we are calculating the reaction for girder ACE and BDF. To calculate the dead load, for the girders, we will do the steel girder due to its own weight. This will be the 490 pounds per cubic foot from the steel, and then we will do the 40, which is the 40 is the area of the girder, which is shown in this here, which is the 40 inches squared. So we will convert the 40 inches squared into feet squared, which we divide by 144. Then we multiply by 1 foot. And from this, we will get 136.11 pounds. We will then draw the girder. This will be A, and this will be E. And then please take a note of the length of the girder, which is going to be 25 plus 10, which is 35 feet. So then we will divide this, be the 10 feet, and this will be the 25 feet, which we can take a note that this will be like point C/D right here, this point. We will draw the distributed load, which is 136.11 pound per feet. And then, as mentioned before, the reactions from the beams will be necessary. So at point A, we will go to beam AB and look at the reaction. We see that it is 2,130.23 pounds, so we will put this point load here. We will then go to beam CD and look for the reaction, which is 7,072.95 pounds, which we will draw the point load here. And we will go to beam EF and look at the reaction at E, which is 5,070.3. We will draw the point load here. We can then go ahead and calculate for the reactions at E and the reactions at E. I have gone ahead and made a clear image of how to calculate for the reactions, and I will post it here. This is how we get the reaction. Once you calculate for the reactions using this, we get that the reactions at A is 9,564.25 pounds and the reaction at E is 9,473.08 pounds. As mentioned before, this is the same for girder BDF. So that is the end for problem 2. Thank you.